We have seen how to construct a confidence interval estimate of the mean when the population standard deviation, sigma, is known. However, that's not the most common situation. Most commonly, we would not know the population standard deviation. So when sigma is not known, we use the student t-distribution instead of the normal distribution, assuming that the relevant requirements are satisfied. So as we've mentioned before, if we only have one value to use to estimate the population mean, we would use the sample mean, because the sample mean is the best point estimate of the population mean. But we would like to be more confident than what we would be with just a sample mean in our prediction or our estimation of the population parameter mu. So we would want to create a confidence interval estimate, a range or an interval of values to estimate, not just a point, but a range or an interval. If a population has a normal distribution, then the distribution given by this formula is a student t-distribution for all samples of size n. So look at the formula here. It looks very similar to the z calculation, x minus mu over sigma over the square root of n. But remember, we use that when sigma is known. Now sigma is unknown. So we're using s in the place of sigma. We're using the sample standard deviation to estimate the population standard deviation. As we'll see, that adds a little more unreliability to our results, so we make our confidence interval a little bit bigger. We'll get to that, but we want to see how we would, in summary, then construct a confidence interval to estimate a population mean when we do not know the population standard deviation. So first we'll look at our notation. So we've seen a lot of these things before. Mu is our population mean. The parameter we wish to estimate. X bar is our sample mean. The point estimate we will use to create our confidence interval estimate. S is our sample standard deviation. N is the sample size, lowercase n. E is our margin of error. And then T alpha over 2 is the critical value. And we'll look at more about how we get that in the next video. Now let's look at the requirements for our construction of our confidence interval. The first one is that the sample is a simple random sample. Recall that that means that all samples of size n have an equal probability of being selected. And either the sample is from a normally distributed population, or we have that large sample size greater than 30. Okay, once those requirements are met, then we can construct our confidence interval and estimate. So let's look at how that would look. It's the same as it was when sigma was known. We take our point estimate minus the margin of error, and that's our lower confidence limit, and our point estimate plus the margin of error is our upper confidence limit. And the margin of error calculation looks very similar than it did before. We just use the critical value T alpha over 2, and instead of sigma, we have S. We also have to consider something called the degrees of freedom, which we will discuss in the next video. Degrees of freedom, N minus 1. Sample size minus 1. In order to get this confidence, the critical value, we not only need our alpha, which comes from our confidence level, but we also need to know the degrees of freedom, which involves the sample size. Another way to state the confidence interval, point estimate plus or minus the margin of error, or in interval notation, x bar minus E, x bar plus E. So the three ways we saw before to express a confidence interval estimate. Okay, these are the basics for constructing our confidence interval estimate, and we'll get into some more detail in the next videos.